Hello everyone, today we're going to tell you about our project on the detection of urea concentration. So firstly, outline. First, we're going to tell you about the theory that we'll use in our experiment. Secondly, we'll tell you our objective, that's our goal in this experiment. Third, we'll tell you the materials that we'll be using. And fourth, we'll tell you about the procedure we'll be following. 5, the measurements. Here we'll tell you how we measure our data. 6, design and data of experiment. Here we will show you the design of our experiment and the outcome of our experiment. So the theory that we will be using in our experiment is that by rubbing two substances with each other, the triboelectric effect will make both substances charged, and grounding one of these substances will produce an electrical current. By measuring the voltage of that current, we can understand the degree of charge transfer between the two substances. So the objective of our experiment is to investigate the connection between urea concentration and the voltage output mentioned in our theory. Equipment and materials. The materials that we will need for our sample is copper wire and aluminum tape. The copper wire has a diameter of 1 millimeter. For the experiment, we will need a muffle furnace, a dip coulter, a rectifier, a voltage amplifier, and a black box. We will be using the black box as the environment of our experiment. The chemicals that we will be using in our experiment are hydraulic acid, deionized water, and urea and PDOT. So now I'm going to give you a brief introduction to PDOT. PDOT is an organic material and it is a polymer. PDOT will be used as a conductor that connects urea and copper oxide in our experiment. Procedure. So first, the procedure for making our copper oxide nanowire. So first, cut several pieces of copper wire with 3 centimeters each. Second, wrap one end with 2 centimeters of aluminum tape. Third, soak the wire in hydraulic acid for 10 minutes. 4, wash with deionized water. 5, dry the wires. 6, put the wires in a muffle furnace at 500 degrees Celsius for 5 hours, then cool the wires down. After making our copper oxide nanowire, we need to combine the nanowire with PDOT. So to combine it, we soak our copper nanowires in PDOT for 1 hour. Data measurements. The procedure for our measurement. So first we'll let our liquid move up and down on our dip coulter, and then we'll adjust the voltage by our rectifier and voltage amplifier. Then we'll input our data into our computer. So this picture shows the setup of our experiment. This picture shows the voltage amplifier and the analog digital converter that we will be using in our experiment. This picture shows the data that will be shown by our computer during our experiment. To process our data, first we need to find the voltage difference between the highest and lowest voltage of the data shown by our computer. Second, we will calculate the difference between the voltage difference of each sample and the voltage difference of the control group. Third, we'll make a scatter plot of the calculated data and make a regression line. Experiment design and data. So the control group and the experimental group of our experiment. So for both groups, we will use our sample for the solid substance, but for the control group, we will be using deionized water, and for the experimental group, we will be using different concentrations of urea. Now our data of our experiment. So in this graph, we can see the voltage output after immersing our sample in 0.5 time PDOT solution. And we can observe that here the R-squared value of the regression line is pretty low. And now let's focus on the dot where the concentration of urea is at 0.15 molar. In this graph, we remove the dot where the concentration of urea is at 0.15 molar, and we can see that the R-squared value of our regression line has improved significantly. In this graph, we can see the voltage output after immersing our sample in PDOT solution. And in the graph, we can observe that the R-squared value of our regression line is very low. And we can observe that the dot where the concentration of urea is at 0.5 molar, the dot is very unusual. In this graph, we remove the dot where the concentration of urea is at 0.15 molar. After removing the dot, we can observe that the R-squared value in our regression line has improved significantly again. Finally, our conclusion. The voltage output is very unusual when the concentration of urea is at 0.15 molar, so we decided to experiment on concentrations near 0.5 molar to find out why. This is the end of our presentation. Thank you for listening.